AI agents are not humanoid robots, but still it can do any task done by a human being. If I train any AI agent to do a repetitive task done by a human being, it is capable of doing it. In this video, we are going to see the five different types of AI agents. Let's see the first type of AI agents. Simple reflex agents. These agents act based on the current state of their environment without considering past actions or future outcomes. They use predefined rules to directly map perceptions to actions. The best example for simple reflex agents are automatic streetlights. They react to their environment like light levels with predetermined actions, turning on or off based on the current conditions, without any learning or memory of past events. These agents respond immediately to their environment using a predefined set of rules. They don't build a model of their surroundings or learn from experience. So, using automatic street lines, they use light sensors like LDRs to detect the ambient light level and switch on or off the lights based on that input. They don't consider factors like traffic volume or historical data to make their decisions. They use predefined rules. The streetlight system is programmed to react to light levels with no ability to learn or adapt to changes in the environment. So that's the reason why streetlights are being as the best example for simple reflex agents. Second type is model-based reflex agents. These agents maintain an internal model of the world, combining current perceptions with memory of past states to make decisions. They can handle partially observable environments where not all information is immediately available. A robotic vacuum cleaner is a prime example of a model based reflex agent. It uses sensors to perceive its environment, stores this information in memory, and then uses a model of the environment to make decisions about its action. In way of perception, vacuum cleaners use sensors like infrared and bump sensors to detect obstacles and dirt, which allows them to perceive their surroundings. They build an internal model of their environment, for example, the layout of the house where they have been. Based on these perceptions and stored informations only, they are making decisions. These vacuum cleaners then uses this model to design on its action, such as which way to move, whether to turn around or not, or when to return to its charging station. These vacuum cleaners remembers which rooms it has already cleaned and learns to avoid obstacles it has encountered before. Third type is goal based agents. These agents operate with specific goals in mind, guiding their actions towards achieving those goals. They consider different paths and choose the most efficient one to reach their objective. Game AI is the best example for goal based agents. In video games, goal based AI agents are used to create more engaging and dynamic experiences, allowing NPCs to formulate strategies, adapt to player actions, and exhibit human like behaviors. In goal based AI agents, they make decisions based on evaluating which actions will help them achieve a specific goal. In video games, these agents are often used to power NPCs, allowing them to react to the player and achieve objectives within the game. Fourth type is utility based agents. These agents prioritize actions that maximize overall satisfaction or utility. They aim to select the best possible action based on preferences or a utility function. The best example for utility based agent is a self driving car. This is because it uses a utility function to evaluate different actions and choose the one that maximizes its overall utility. A self driving car's AI uses a utility function to assess various factors like speed, safety, fuel efficiency, and comfort. When it comes to decision making, the AI selects the action with the highest utility score, considering multiple goals and trade offs. For example, it might choose a slower but safer route in snowy conditions. Utility based agents are particularly effective in dynamic environments where multiple factors influence decision making. For example, a self driving car might prioritize safety when driving in heavy traffic or fuel efficiency when making a long trip. It is not just goal based. While self driving cars have a destination goal, they don't just focus on binary success, achieving the goal or not. They optimize for the quality or efficiency of achieving the goal. Fifth type is learning agents. These agents can adapt and improve their behavior over time through experience and learning. They use various machine learning techniques to refine their decision making process. Algorithmic trading system is the best example for learning agents. They interact with environment by observing financial data like prices and volumes and making trading decisions in real time. They also learn from experience. They improve by analyzing outcomes, profit or losses, using algorithms like Q learning or deep reinforcement learning. They use adaptive policies like DRL to enable dynamic strategy adjustment to balance risk and reward in volatile markets. In autonomous trading system, we use autonomous decision making. These agents make trading decisions without human intervention to optimize performance. Here, the main goal is content-based improvement. They refine strategies over time based on accumulated market experience and feedback.